Hey everyone. So this is going to be the second lesson in the unit, all about rational exponents. So like with everything, you should try working out these questions yourself. Use the video as a guide. Um, and let's begin. So for this do now. So what we're going to do with a lot of these, it's going to be, it looks like it's a lot of the power rule. So we're going to take this exponent and bring it over, distribute, multiply by the 3 that we already have. So 3 times 4 is 12. And the next one, we end up having x to the negative 2 times 5. So again, multiply the negative 2 and the 5, we get x to the negative 10. Now here we have a negative exponent, so we're going to move it into the denominator and make that negative 10 a positive. For C, we don't have to do anything crazy because anything multiplied by 0 is 0, and anything raised to the 0 power is just 1. And then over here, we can actually do the power rule twice. So we can move the 2 times the negative 2 there. So we get negative 2 times 2 is negative 4. Do the same thing with these two 4s. So 4 times negative 4 ends up being negative 16. And again, just like with part B, we're just going to move the x to the 16th to the bottom and turn that 16 into a positive. All right. So here, if we look on the directions, it says that they want us to use our calculator to figure out what each of these are. So now we're going to actually add in these half exponents. So if I put in the calculator 25 to the half power, we actually see that this is equal to 5. 81 to the half power is equal to 9. And 100 to the half power is going to be 10. So the question is, what do we notice about what happens when we raise things to the half exponent? Well, it turns out that this is the equivalent of saying square root, because the square root of 25 is 5, the square root of 81 is 9, and the square root of 100 is 10. So an exponent of a half represents a square root. All right. So here, a rational number can be expressed as a fraction. Any number that can't be written as some form of a fraction is not considered a rational number. So our exponents that we're going to talk about are going to be fractional exponents. Now here, if we have a rational exponent that's m to the m over n, like here, then what that really means is that we're turning the over n, the fraction part, into some form of root. So the top number ends up being the power that the number gets raised to, and the bottom number ends up being the root of that number. So in the case of our examples up here, when we had something like a to the 1/2, this is the equivalent of taking the square root. If this was instead a to the 1/3, this would end up being a cube root. Or a to the 1/4 would be a fourth root. And then the powers act exactly the same way that we did before. All right? So scrolling down, going to these practice questions, trying these out ourselves. So what we're going to do is we're going to just rewrite these all with roots rather than their exponents. And we don't actually have to solve anything. since a lot of these actually can't be solved into actual numbers. So you're not plugging anything into the calculator. So again, just like we saw before, since I have a fraction, the 125 is now underneath the fraction, and the 8 that's in my denominator gets pulled out in front of my root. So this is going to be an 8th root of 125. I could do the same thing here. So doing a little bit of that power the product rule. So this becomes 3, 2 over 5. Now, because of the fraction, it means that this number is now going to be underneath a root. And the 5 that's in the denominator gets pulled out in front of my root. So this is just going to be rewritten as the 5th root of 3 squared. 3 squared can be rewritten as 9. So now my simplified form is the 5th root of 9. Over here, this is going to be a little bit trickier. So what we're going to end up doing, because of the quotient rule, we're going to subtract these exponents. Now remember, we have to have similar bases in order to subtract fractions. So this 1 over 3 actually becomes 2 over 6. So 1 over 6 minus 2 over 6 can be rewritten as x to the negative 1/6. So the negative just means that it goes in the denominator. So this becomes 1 over x to the 1/6. And this fraction means that there's going to be a 6th root of x. And this last one, so I'm going to get rid of the negative first. So the negative means that the 32 is now in the denominator. Now that 1/5 becomes positive. And the 1/5 tells me that it's going to be a 5th root of 32. And that's pretty much it. All right. If I scroll down some more, we could see some more where now we're actually going the opposite way. So here, the 4th outside the root means that it's going to be 1/4. So 5 is in the numerator since that's my power, and 4 is in the denominator since that's my root. We're going to do the same thing here. So this becomes 7 to the 1/6. It's being squared. This 2 gets multiplied by the 1/6. So it's going to become 2/6. Simplifying that fraction, this actually becomes 7 to the 1/3 power. Okay, for this term, again, the rational exponent is going to be the power, which is 5, divided by the root, which is 3. So a to the 5 over 3. For this one, what we're going to do is we're not going to multiply these or anything. What we're going to do is figure out what the exponents are. So we're going to do x to the 1/3 for that cube root, and x to the 1/2 for the square root. Now I use the product rule. I'm going to add these exponents. So 1/3 plus 1/2. Now I have to get similar bases. So 1/3 is actually going to become 2/6, and 1/2 becomes 3/6. Combining that actually becomes 5 over 6. Now, if you aren't comfortable adding fractions, you can always just use the calculator. You just need to make sure that you set it to fraction form. All right. So doing something similar that we did in the previous section. So this becomes a cube root of y. So the negative tells me that the x to the 1/2 is in the denominator, and the 1/2 tells me it's a square root of x. All right, so because my whole exponent is negative, this is now in the denominator. the half, the 2 in the denominator, tells me this is going to be a square root. Oh, sorry, that should be a positive 3. And my power is still 3. So I end up having that. Going over to these 3. Now, the exponent is only on the x. So I'm not looking at the 4. The 4 is actually outside. The 3 in the denominator tells me it's a cube root, and my power is 2. This time, the 2/3 is on the outside of the parentheses. So both terms are getting the 5a squared cube root. So the 3 in the denominator tells me it's a cube root. The square up top is the power. I'm going to distribute that square to each term. So it becomes 5 squared a squared. Plug it in the calculator, 5 squared is 25. Now I can't do anything with that. So that's my most simplified answer. All right, over here, we're going to, so I don't want to actually get rid of this negative because I'm going to have to subtract these. So I'm going to do 1/6 minus 2/3. Again, the minus and negative actually means I'm going to be adding these exponents. And to get similar bases, I have to turn this into 4/6. So this actually ends up becoming y 5 to the 6th, 5/6. So this becomes a 6th root of y to the 5th. So you should start to see kind of the repetitiveness of a lot of these things. All right, so for this can be rewritten as 16 to the 1/4. Now actually, I'm pretty sure, yeah, so just as an FYI, this can also be rewritten as 2 if you put it into the calculator. But they wanted it strictly with rational exponents, so we're not going to change the 16th. This would be the accepted answer. All right, for this, the a is going to be raised to a 1/5 because it's a 5th root. Here, the 2b are both being raised to the power of 1/3 because both 2 and b are underneath that cube root. And similar thing here, this y is going to be raised to a 1/3, but because of that 4 on the outside, I have to multiply the 1/3 by 4, and I get y to the 4/3. So again, you should be able to go back and forth between all these different ways of writing with rational exponents. Okay? So with this, the negative brings the x to the bottom. It becomes positive 1/5, and this becomes a 5th root of x. Here, the root is 7, and the power is 3. We move the whole term to the bottom because of the negative exponent, and the root is 2, and the power is 5. Right. Over here, I guess we'll distribute the 4/3 each term. Now 3 times 4/3 is actually just going to be a 4. And this ends up being 8. Okay, so this ends up being a cube root of 64 to the 4th, x to the 4th, divided by 8. Now, you may actually want to put this in a calculator because the 64 to the 4/3 can be rewritten as 256 x to the 4th divided by 8. And when we divide that by 8, this actually simplifies to 32 x to the 4th. So that is the most simplified way of writing this number. And then over here, so the claim is that the square root of a cube root is the 6th root. So let's see if this actually makes sense. So the cube root is x to the 1/3. Taking the square root of that is essentially doing this, putting the 1/2 on the outside. Then when we move the exponent to try to simplify, we bring it in, we multiply 1/3 times 1/2, which gets us 1/6, which is a 6th root of x. So yes, she is right. The square root of a cube root is a 6th root. All right, and that's pretty much it. So again, we did some practice with the rational exponents, moving things around. If you have any questions, please feel free to let me know as soon as possible. Like I said, you can watch this video a few times if you weren't too sure, but try to see how much you can answer by yourself. All right, see you later. Have a great day.